Hi folks, Chris McClure. I'm going to have a quick discussion on how to do polynomial division in the special case when you are dividing a polynomial by a binomial of the form x plus or minus a number. Alright, so this special version is called synthetic division. Now, as a reminder of how we do polynomial division, this is an example, right? Suppose that we have 2x cubed minus x squared plus 0x plus 3 divided by x minus 3. And we compare the leading term of the divisor to the leading term of the dividend, x versus 2x cubed, and we ask the question, how many times does x go into 2x cubed? And the answer, of course, is 2x squared. And then we multiply 2x squared times x to get 2x cubed, and 2x squared times negative 3 is minus 6x squared. And then we subtracted, right? We subtracted negative x squared minus negative 6x squared is positive 5x squared. And we had a plus of 0x. And then we ask ourselves the question, how many times does x go into 5x squared? The answer is 5x. And we multiply 5x times x minus 3 to get 5x squared minus 15x. Subtract 15x plus 3. X goes into 15x, 15 times? 15 times x minus 3 is 15x minus 45. Subtract, you get 48. So we get a remainder of 48. Here's our quotient. Now, in the special case where the divisor is a binomial in the form of x minus a number or x plus a number, it turns out that this whole polynomial long division process can be simplified. So imagine that this 2x squared, this x squared and stuff, this, automatically that this is going to be the same thing as that. So you can eliminate that. You know that these are going to be the same, these are going to be the same. So you can actually cut out a lot of notation from this process here. So look at over here on the right, we've cut out a lot of stuff right here. Alright, so what really matters is seeing this 5, this 15, this 48. We know this 48 is a remainder, huh? So if, as you look through all this stuff, we could see how step by step, we will make it more compact. Take a look at this step right here. Where we bring down the 2. 2 is the leading coefficient for the dividend. And also, see this negative 6? Because we're subtracting, you might as well, when you are subtracting a negative number, you add, right? So that's why you see that instead of subtracting these numbers here, we are just adding, right? Adding the negatives of those. So essentially what we're doing is a way of simplifying all this polynomial long division stuff. All we're simply going to be doing is taking a look at this 3 right here. Okay. So I'm going to show you the process of how all this goes. See all this right here? This is just distillation of these numbers right here, together with this one. So here's what synthetic division does. It just is a simplified, compact way of doing polynomial long division when you see your divisor in that form. So if you're dividing by x minus 3, then you'll put a 3 right out front. And you'll put the coefficients of all your dividend terms right under the division symbol. See the 2 and the -1 and the 0 and the 3. This means 2x cubed minus x squared plus 0x plus 3. And what you do is you bring down the 2 here. The 2 as in that leading coefficient for the dividend. And then you're going to multiply 3 times 2 to get 6. And then you add. -1 plus 6 is 5. And then you multiply this 3 times the 5, which is 15. Add 0 plus 15 is 15. And then 3 times 15 is 45. So 3 times 15 is 45. And then 3 plus 45 is 48. You see what we did there? In just a matter of seconds, we accomplished doing all this polynomial long division here. We did exactly the same sequence of steps, just in a more compact form. Okay. Okay, so let's take a look at an example of how we're going to do this. X cubed minus 4x squared minus 5, divide that by x minus 3. Alright, so go ahead and write the coefficients for the dividend. 1, -4, 0 for the x term, and the -5. And then because we're dividing by x minus 3, we'll put a 3 on the outside of this division symbol. And then we'll draw a little horizontal bar here. Bring down the 1 from the leading coefficient. We'll multiply 3 times 1. 3 times 1 is 3, so we'll put the 3 there. Then we will add -4 plus 3 is -1. Multiply 3 times -1. Give you -3 right here. 0 plus -3 is -3. 3 times -3 is -9. -5 plus -9 is -14. What you're looking at right here, all these numbers to the right of that very last number on the bottom row are the coefficients for the quotient. This tells me x squared minus x minus 3 is the quotient, with the remainder of -14. So there's your quotient, that x squared minus x minus 3, with the remainder of -14, which is this guy right there. Okay? Here's another way to check your work, though, is to take what you believe is the answer, x squared minus x minus 3, multiply it by the divisor of x minus 3, and then add -14. When you do that, multiply that out, you actually end up with the dividend, which verifies your work. So there's your answer of doing that artificial or synthetic division. But again, this is only going to work when you're dividing by a binomial of the form x plus or minus a number. If you're dividing by x plus 3, then you would have a -3 out front there, together with the coefficients of your dividend here. Okay? Okay? So let's now verify that x plus 3 is a factor of this polynomial here, 2x to the 5th plus 5x to the 4th minus 2x cubed plus 2x squared minus 2x plus 3. In order for us to show that x plus 3 is a factor, is that when we do the division, that there would be a 0 remainder. So we can go ahead and do the synthetic division. I'll let you look at this division. Notice that these numbers right here under the division symbol are the coefficients for the dividend. and then the minus 3 out front comes from the fact that x plus 3 is the same thing as x minus negative 3. So we have negative 3 times this 2 that we had brought down. Negative 3 times 2 is negative 6. 5 plus negative 6 is negative 1. Negative 3 times negative 1 is 3. Bring that up here. You know, add, multiply, and so forth. Notice that we end up with the remainder of 0. So what we've just shown is that when you take this binomial, this, x plus 3 polynomial, which is a binomial, or a polynomial, I should say, divided into this polynomial, you get a remainder of 0. That tells you that x plus 3 is a factor of that larger polynomial. And you can verify your work by multiplying the quotient times the divisor and verify that you get the original dividend. By the way, the remainder was 0. Okay? So we verified that x plus 3 was a factor of that larger polynomial. Okay, folks, so that is the synthetic division. You will have plenty of opportunities to use this in the future. Okay? Well, we'll see you in the next section, okay? Talk with you later. Goodbye.